Hello students, so we had discussed about uniform acceleration, accelerated motions, right? We had derived three equations for uniformly accelerated motions and we had solved the questions based on those equations, right? Now today we are going to discuss a new topic, that is acceleration due to gravity. Acceleration due to gravity. Okay. We'll understand the sign conventions, few rules to solve the questions based on gravity. First of all, what is acceleration due to gravity? Okay, when any object performs the motion under the influence of gravitational force, then the acceleration developed in the body is known as acceleration due to gravity. That means suppose if I am leaving this object, I am not applying any kind of force on this object, I am just leaving this object, it will go down, the motion will be in downward direction because of the gravitational force of the earth. Earth's gravity will attract this object towards itself, right? So the object will perform a downward motion with increasing velocity. Velocity of the object will keep on increasing, but the acceleration developed will remain the same, and that is known as acceleration due to gravity. Let's make it more clear. Whenever an object is performing the motion only under the influence of gravitational force, that is because only of gravity, if the object is performing the motion, it is said to be motion under gravity, and the acceleration of the object is known as acceleration due to gravity. That means if I am leaving this object, so one thing is sure, I have not applied any external force on this object, I am just leaving this. So when I am leaving this, it will come down, it will go down, right? So the force on this object will be because of the gravitational force of the earth, and because of that this object will be performing downward motion. So suppose this is earth, right? I am just leaving this object from say any height h, so it will be coming down. Earth's gravitational force will attract this object, right? So the acceleration developed in this object is known as acceleration due to gravity, whose value will be 9.8. That means we can say every second the velocity of this object increases by 9.8. Velocity of this object will increase by 9.8. So acceleration will remain constant, which will be 9.8. That means suppose here at t equals to 0, velocity will be 0. Of course, always remember one thing, whenever any object is performing free fall, this is known as free fall. Free fall means you are not applying any kind of external force, you are just leaving the object, but the object performs the motion under the influence of gravity. That is known as a free fall. Whenever any object is performing free fall, its initial velocity will be 0. Initial velocity of the object performing free fall is always 0. Whenever any object performs motion under the influence of gravity, or when any object falls under the influence of gravity, or when any object performs a free fall, its initial velocity will be 0. So let us say t equals to 0, v0 equals to 0. After 1 second, velocity will increase by 9.8. After 1 more second, velocity will be 19.6 and so on, right? So acceleration means change in velocity by time. So when the object is performing a free fall, its acceleration will remain constant, which is 9.8. Clear? If I am applying a force on this object like this, then initial velocity will not be 0. Initial velocity will be 0 only when it is performing a free fall. I am just leaving this object. So just now the initial velocity of this object will be taken as 0. Clear? Clear? When object moves down, its velocity keeps on increasing, acceleration will remain same, and this acceleration is known as acceleration due to gravity. So in this case also, it is performing uniform accelerated motion. Of course, it is performing uniformly accelerated motion, and acceleration is constant, which is given as 9.8. Clear? Clear? Now so one thing is sure, what is motion under gravity and why initial velocity of a free fall is always taken as 0. These are the questions which we have answered. Now we'll learn few rules which we need to apply for solving the questions based on gravity. Okay, see. And here's those equations which we had derived in the previous lecture were for uniform acceleration. So the same equations can be applied over here also, because in our case also acceleration is remaining constant. The thing is that our acceleration is acceleration due to gravity, but it is constant. It is constant. Right? So those equations can be now written as, so this was our equation, v equals to v0 plus at. The same equation we can write it as, whenever object is performing motion under the influence of gravity, this equation can be written this way. Initial velocity will be 0. See, when object is performing the motion under the influence of gravity, so one thing is sure, that object is moving under the constant acceleration, So those equations which we had derived for constant acceleration, same we can apply for motion under gravity. Only there are minor changes which we need to make. Right? See, this was the equation v equals to v0 plus at. So same thing if we are to write for the gravity, motion under the gravity. So v0 we are taking it as 0 plus gt. So first equation will be v equals to gt. Right? The second equation was displacement is v0 t plus half at square. This was our displacement. Now object is performing free fall. So this will take it as h. v0 is 0, half, instead of a it will be gt square. Got it? Clear? So this will be our second equation. Third one was v square minus v0 square equals to 2ad. Right? The same can be written here. V square initial is 0 to gh. So these are the three equations to be used when object is performing motion under the influence of gravity. Of course, we have derived this equation from this. We just have made minor changes from this equation in order to obtain this equation. Clear? Clear? These equations which I have written, these are for the object or for the body performing free fall, or when the object or a body is performing motion under the influence of gravity. Gravity means with constant acceleration. For that we will use these equations. Okay, but here we have not applied any sign conventions. That means we have not applied any sign. First we will understand the sign conventions which are to be applied while solving the questions of gravity. See the first one. Take velocity and displacement positive, okay, in upward direction. Take velocity and displacement positive in upward direction. Or when the motion is in upward direction, take velocity and displacement, of the object take velocity and displacement of the object moving in upward direction. Right, that means if I am throwing any object in this direction, upward direction, then the velocity of the object and the displacement both are taken positive. Take velocity and displacement to be negative when they are moving in downward direction. We'll understand this with the help of a diagram, also with the help of a figure. Always take acceleration due to gravity as negative. So it's not compulsory that you will have this rule. In few books and few cases, I mean, we can in few of the reference book it is given that take G as positive in one direction and negative in another direction. That will be also okay, but this will be easy to remember that always take G as negative. Acceleration due to gravity, always take it as negative. Whether the object is moving in upward direction or whether it is coming in downward direction, take G as negative. Right? Once again, we'll understand the sign. You have to take both the velocities and displacement positive if the object is moving in upward direction. Take velocity and displacement to be negative when they are moving in downward direction. Always take G as negative. Right? These are the three simple rules which are to be followed while solving the questions based on gravity. That means the rules which are written here, let us understand that with the help of a diagram. This is Earth. If I am throwing anything, if I am throwing an object in upward direction, right, this way, and take its velocity and displacement as positive, right? If this is Earth, the object is performing free fall, that is, it is coming in downward direction, it is performing free fall, it is coming in downward direction, then displacement of this object and its velocity both are taken negative. Clear? And in both the cases, take acceleration due to gravity as negative. So in this case also, take acceleration as minus G, acceleration as minus G. We'll solve few questions based on gravity, so it will be more clear to you how to apply sign convention. These are the rules which are given in mostly every book, but apart from this, we'll understand one more thing. See, what if this is Earth, ground, this is h height of a building. Now I am throwing an object from the top of the building in this way. So it will first go this way and then it will hit to the ground this way. Right? So now in this case, what to take the displacement? Positive, negative. Clear? First, h is the height of a building and I am throwing an object in upward direction. So the object will be going this way and then it will be coming back to Earth. So now what to take the displacement of this object? Whether I will take displacement as positive, displacement as negative. Then look at the final position. Look at the final position of the object. If final position of the object lies below the initial position, final position lies below the initial position, take displacement to be negative. Right? That means in our case, this is the final position. This is the initial position. From this position you are throwing the object and it reaches over here. That means in our case, final position lies below the initial position. Right? So when final position lies below the initial position, take displacement to be negative. This is an important point. This should be noted that if final position of the object lies below the initial position, take the displacement of the object as negative. And here's take velocity, initial velocity, you are throwing in upward direction. So V0 will be positive, D will be negative, G will always be negative. Clear? Clear? Displacement will be negative, right? V0 will be positive and acceleration due to gravity will always be negative. Now, what if the final position lies above the initial position? That means this way. This is any height h, this is any another height h dash. I am throwing an object from h to h dash this way, right? So now this is the final position of the object, this is the initial position of the object. In our case, in this case, final position is at higher point. Final position lies above the initial position. So in this case, take displacement as positive. Clear? Velocity as positive. G will be taken negative. Clear? G will always be taken negative whether the object is moving in upward direction, downward direction, in whatever direction the object is performing the motion. Always take G as negative. Clear? These are all the rules which are to be followed to solve the questions based on gravity. Clear? Clear? Take initial velocity for a free fall. For a free fall, take initial velocity as 0. Right? Take the direction of displacement and velocity to be positive if they are performing or if they are moving in upward direction. If they are moving in downward direction, take both the velocities and displacement to be negative. Always take acceleration due to gravity as negative. If final position lies below the initial position, take the displacement as negative. And if the final position lies above the initial position, take displacement to be positive. Clear? Right? So this was the explanation about the topic of acceleration due to gravity. So in the next video, we'll solve the questions based on acceleration due to gravity, where we'll understand how to apply these rules and how to get the answer. Clear? So after solving few questions of gravity, we'll get a clear idea how to use sign convention. Okay?